number 3 topic is a stereo centers, and this stereo center is essentially carbon with 4 different attachments. Okay, and that's what we call the. We're going to put a little star asterisk sign on there. So this star marks on the carbon with 4 different attachments, and so that what that means is this one is sp3 hybridization, carbon with that hybridization, and you need to have those 4 attachments are all different. So I'm going to put it in like that, I'm going to put it like this, I'm going to put it like that, I'm going to put it like this. Okay, why is that is nicely explained in here. If you look at this, it's a compound. Once again, this is an sp3 carbon, right? And with the 4 attachment here. And this one has a hydrogen, amine, organic carboxylic acid, and some kind of R, right? And you can put it in the 4 different attachments, the same 4 attachment, but in the 3-dimensional way, you can put the other one. And this is your left-hand side, and this is a right hand, right? So this is one of my favorite kind of demonstration that your left and the right hand side is not the same hand. So trying to put the right hand side glove on your left hand, it would not fit. So does the many compounds in nature. You notice that this is actually what we call the amino acid. Here is an example of an amino acid. Amino acid is a building block for proteins and what our bodies are made out of. And because of this stereochemistry, and this carbon is essentially not superimposable, so this is what we are saying is these are the isomers, right? And we call chiral isomers. So the only difference is their response to the polarized light. So that's why chiral has something to do with the light. And they are different. Okay, they are different, and it's very important in biochemistry or even medical field to understand that stereocenter chemistry, because a lot of medical chemicals are all related to this. Essentially, carbon centers. Carbon molecules have stereo centers. You need to understand that. Okay, so they are different. So, in a simpler way, once more, it is more. This is a tetrahedral, sp3. So these are the 4 carbons, and then here once more, COH and hydrogen, nitrogen, with amine, and then I can put, for example, methyl, right? So this is a stereo centers, for example, in shown up here. So let's look at here and where we can find the 4 different attachments, and then you will easily find out. This one, for example, here, okay, 3 different hydrogens. Okay, if your 2 attachment is the same, it cannot work. So this is a 2 hydrogen. I know here. There are 2 hydrogens, so although it's an sp3, this one cannot be, this one cannot be. So does the other one. But if you look at here, that's where I can put here, because this is a one sp3 carbon with 4 attachment, OH, not OH, something like, to be exact, CH2, CH2OH, and chlorine, and then, so let me get rid of this, it's a little too much. So 1, 2, 3, so I think the propyl, and then this one is propane. You don't have to write this way like I did. Propanol, propanol. Okay, so those are the 4 different attachments, and that you see. So that's where what this question is asking you is identify the stereocenters, and then you just write it as with a star sign on here, just like I do here. So let's look at these problems, and as you can see, this is a good candidate, and I know one missing line is an implied carbon-hydrogen bond, so this will be the position of the stereocenters. So please note that once more, this is a three-methyl attachment, so cannot be, right? Cannot be stereocenters, and so does the other one. So there's only one stereocenters, and that's the one we can have it here. So another name, so it has a many different name, stereocenters, stereoisomers. Sometimes people call mirror image isomers, or sometimes people call right-handed left-handed molecular centers. Okay, so that's what people also use that in their nomenclature. So identify the types of one. So as you realize in the previous one, the double bond in cis and trans, now we are talking about something about even as simple as sp3 carbons that can have a stereoisomer centers. We call chiral centers. Thank you.